now going to look at antiderivatives. So the first question is, what is an antiderivative? Well, we say that capital F of t is an antiderivative of f of t if capital F prime is equal to f. So essentially, an antiderivative is the opposite of the derivative. If I have a function, its antiderivative is something that has this as its derivative. And our shorthand notation for this is we write f of x, the integral of f of x equal to dx is equal to our antiderivative. So let's do a couple of examples and see if we can figure this out. Let's look at the integral of 7 dx. So what we're looking for is something that has 7 as its derivative. And one of the things that we might be able to come up with is 7x. Because if we try to take the derivative of 7x, we get 7. But that's not the only thing. I could also do something like 7x minus 12. And then when I take the derivative of that, the derivative of 7x is 7, and the derivative of negative 12 is 0. So the way we write this is we say that the antiderivative is 7x plus c. And in general, the integral of a constant a dx is going to be ax plus c. And what this plus c means is that I can actually add or subtract any number, any constant to the end of this, and it's still an antiderivative. Let's look at some more. Now I have the integral of 4x squared dx, and I want to find its antiderivative. So, whenever we take the derivative, for instance, of x cubed, I bring the number out front and subtract 1. So when I'm going backwards, I'm going to have to add 1 to the exponent. So I know this is going to be an x cubed. However, what about the constant? Before I multiply over here by 3, let's see if we can figure out what it needs to be. The derivative of 4x cubed is going to be, well, we bring the number down and get 12x squared. Well, we don't want a 12x squared, we want a 4x squared. So we need to divide by 3. So if I divide both sides by 3, then the derivative of 4/3 x cubed is 4x squared. So my answer is 4/3 x cubed, once again plus c. In general, the integral of x to the nth power is going to be 1 over n plus 1, and then x to the n plus 1. We add 1 to the exponent and then divide by that number. What about the integral of 1 over x dx? Well, we can't use our power rule anymore because we'd be dividing by 0, so that doesn't work. So we have to think, what has a derivative of 1 over x? And the answer is the natural log of x. So the integral of 1 over x is ln of x plus c. What about the integral of sine of x? Well, we know that the derivative of cosine of x is negative sine of x. So the integral of sine of x is going to be the opposite and have negative cosine x. Once again, plus c. For the integral of cosine x, well, we know that the derivative of sine is cosine. So the integral of sine, to go the other way, is just, the integral of cosine is just going to be sine x plus c. For my last example, what about e to the x? Well, I know that the derivative of e to the x is e to the x. So going the opposite direction, the integral of e to the x is also e to the x, and once again, plus c.